Okay, so today we are going to be working on page 5 of the second packet that I handed out. And we are going to do lesson 2 on proportional versus non-proportional relationships. So we're going to figure out if a linear relationship is proportional from a table, then from an equation, and then from a graph. So let me get this positioned. Okay, so right here it says a proportional relationship between two quantities is a relationship in which the ratio of one quantity to the other quantity is proportional. So they mean when you go to this table right here, you're going to calculate, you're going to write each one of these as a ratio. And if each one of them simplifies to the same number, then this table and this relationship will be proportional. So let me show you what I mean. So we're going to go, this would be like your X and this would be your Y. So the first set of ordered pairs right here, you're going to write as a ratio of Y over X. So 60 over 1. The next one, 120 over 2. 180 over 3. 240 over 4. So when you simplify each one of these, they all come down, or you divide 120 divided by 2, they all turn out to be 60, which means this relationship is proportional. So we can say yes. This is not going to be, in the future, how we will be calculating our constant rate. So I am not going to spend any more time on this right now. The next one, we have equations. So a proportional relationship can be written as an equation in the form of, don't get dizzy, y equals kx. So over here are 4 equations. We're going to relate this to the lemonade story, these equations. Let's pretend that the K is how much we charged, or how much my daughter and her cousin charged for the lemonade. And then this might be what they started with. So if you look at these equations, there is no cost. Remember we said maybe it was going to cost them $20 for the supplies for the lemonade stand? Well, if that was the case, there'd be a minus 20 here, right? But there's nothing. This means they started out flat even. Maybe their mother bought the stuff for them. And this would be like I'm just pretending, relating this to a lemonade stand. This would be $12, a very, very delicious cup of lemonade. So $12 per cup. That's how they're going to tell. This is proportional because they started out at 0. So this is proportional. This would be 75 cents per glass. And this means that they did not start out ahead or below the game. They, again, my sister-in-law probably purchased the stuff for them. This is proportional. Why? Because there is no value constant right here. This right here means, oh, somebody threw $1 in their bucket at the beginning. So they actually started out with $1, and then they're charging $6 a glass. Because they didn't start out at 0, this is not proportional. Because there is a value right here, a constant, this is not a proportional relationship. It does not start out at 0, 0. This right here, 25 cents a glass, there is no constant value here. This is proportional. And we'll come back to this many, many times. So from a graph, which is my favorite, the graph of a proportional relationship is always a straight line that goes through the origin. So the graph of a proportional relationship is always a straight line that goes through the origin. And I'm going to start to show you up here. When we get into this, you could figure out that this starts at 0, 0 by working this pattern backwards, and I will eliminate this process completely. So just looking at the graph, you can see that it passes through the origin. So this is a proportional relationship. Bink. Okay, these are tricky because you have to fill in your own table. So you have to make sense of the situation on your own and then be able to graph it. I told you I could graph. If I wanted to, I could graph the lemonade stand for my daughter. Again, I told you she was not interested, but I could have. But I held off. I had her feelings in mind. We're gonna call that an 8. So we're gonna say Dakota earns $8 an hour at his part-time job. I don't really know what that says. It's so blurry. So y equals 8x. So your constant rate is 8. So he always gets paid $8 an hour. So you can make your chart. Time in hours is typically your x values, or would typically go on your x-axis. So we're going to say time in hours on the top of the table. That says time. Let me fix that up here. Okay. Does that look like it? Yeah. Okay. Pay. Here comes my dog. All my animals have just followed me into the room. Waiting for my cat to jump up here. All right, so let's just figure out, okay, say we worked 1 hour. How much money would we earn? 8 times 1 is 8. If we work 2 hours, it'd be 8 times 2, which is 16, and so on and so forth. This is what we're going to do right now. My dog is making a mess behind me. I have to go address it. Hold on one second. Hold on. I'm back. Okay. This is going to happen. I told you. This is not my kids. It's my dog. All right. We're going to put it on a graph. And so we're going to put the time down here. We're going to label our axes in hours. We're going to say part-time pay for the title. And then on the y-axis, what are we getting? Pay. I keep putting A's. Oh, it's too early in the morning. Okay. Pay in dollars. All right. So we can just go across the bottom. Each box is worth 1. That works. Everything fits. On the side, you have to be consistent. You could go up by ones, 1, 2, 3, 4, 5, but it's not going to fit all your data up to 40 because your y-axis has to go up to 40. So we'll go up by 5s. Does that work? 5, 10, 15, 20, 25, 30, 35, 40. So it fits. We need to be able to go to 40. It goes to 40. So I'm going to go up by 5s. You could go up by 10s if you wanted to. It just makes it a little harder to graph the more you have each box worth. 25, 30, 35, 40. And then you're just going to plot your points. So 1, 8 is here. 2, 16 is about here. 3, 24 is about here. 4, 32 is here. And 5, 40 is here. This should make a straight line. So what I'm going to do now, I got to show you my cat. What are you doing, Jace? She found the catnip. Good morning. Okay, there she is. That's my cat, JC. She follows me everywhere I go. Everybody follows me everywhere I go. It doesn't matter who it is or if it's an animal or a child. Okay, I need some paper because I don't have a straight edge. So whenever you draw a line, graph a line, you need to use a straight edge. There's always something around. So let me show you. I'm looking around right here. I'm looking around. I got this piece of paper. I'm going to use it. You might have a ruler in your agenda. I'm not sure. So we'll talk about that. But the agenda at the school I used to teach at, they always had a ruler in there. But please don't sketch, okay? Please don't draw your lines on a graph by hand. Always find a straight edge. I am going to make a big deal out of that one. Okay, that's the lesson for today. So the gist of the proportional relationship is it starts at 0, 0. So that lemonade stand, did they start out and they didn't have to purchase their supplies, or did they come in having a debt? Basically, they paid $20, and in order for them to make a profit, they need to bring in at least 20. That would be proportional, non-proportional. Okay, so for right now, you're going to practice page 6. On the next page, independent practice. Remember, it's all about just seeing how well you understand this, knowing when you come into class where you stand with this particular skill, and it is okay to not know stuff. In fact, the entire purpose of me giving you the assignment is to find out what you don't know. And then when you come into class next time, maybe circle the questions that you have, and I will go over them with you. Good luck, and we'll see you soon.